Today we're going to test out two different preparations for propionic anhydride. In the previous video we showed you how to make a solution of elemental bromine in dichloromethane. We're going to use this in our first experiment today. We store ours in deep freeze together with calcium chloride to keep it dry. For both preparations today we prepared a batch of anhydrous sodium propionate, and we melted this to ensure it's completely water-free. For the first experiment we're going to use 50 grams, which we weighed out ready and then covered with film to stop it absorbing any atmospheric moisture. As you can see, it's in little chunks where it has solidified after melting. Here's our first setup. We're using the 500 ml flask, which has a thermometer in it so we can record the temperature. We've also got a magnetic stirrer in the flask, and the apparatus is sitting in an ice bath. We don't know if this is going to be exothermic or not, so we want to be careful just in case. Here's our bromine solution in dichloromethane. We have 57 ml of solution, which weighs 97 grams. Doing some maths we can work out that this contains approximately 35 grams of bromine. So first we'll add this to the flask. Okay, here we go. The temperature in the bath and in the flask is around 5 degrees C. Here's our next ingredient. This is 15 grams of dry finely powdered sulfur. Let's add a bit to the flask and see what happens to begin with. We're watching the temperature closely, but there's no change. And no visible change inside the flask. So we keep the addition going. We add all of the sulfur to the flask and there's still no temperature increase. In hindsight we could have probably guessed this, but better to be on the safe side. We notice that there are still quite a lot of sulfur in solid form suspended in the liquid in the flask and not dissolving and reacting. So we removed the cooling bath temporarily and allowed the mixture to warm up to room temperature. It's a hot day, so that's about 25 degrees. After about 15 minutes we noticed that all the solid had reacted and gone into solution. We now put the flask back into the ice bath again. And now we're slowly going to add the anhydrous sodium propionate to the flask. We did this slowly because we know that when you do this using acyl chlorides the reaction is highly exothermic. And a little more. After adding half, the temperature has gone up by about 10 degrees. So again, it's not actually that exothermic after all. Here we are with all the sodium propionate added. It's a little difficult to stir, but the stir bar is just managing. Temperature after complete addition is about 25 degrees C. We took away the cooling bath and then stirred the mixture a bit more vigorously for about 10 minutes. Then we set up a reflux condenser and gently began to heat the flask up to the boiling point of the dichloromethane. Slowly we could see the color of the liquid changing to a paler orange, and the lumps of sodium propionate began to break down. And pretty quickly we've got a nice gentle reflux going on. We left this refluxing for the next hour. Over this time the mixture became a paler orange still, and the solid completely broke down, forming a fine powder in suspension in the liquid. The condenser keeps anything from escaping, but if you open the flask there's a pretty mean sulfurous aroma at this point, which is quite unpleasant. After an hour we allowed the flask to cool a bit. And then we swapped around the apparatus. Setting up for simple distillation of the flask contents. We're using the heating mantle now so we can apply strong heat. And we're using the thermometer so we can see what's coming off. First to come off was the dichloromethane solvent, originally from the bromine solution we added, although it's distilling with a yellow color. It's possible that we've got some unreacted disulfur dibromide, our intermediate, coming off as well. Distillation of the DCM at around 45 degrees continues, and the temperature slowly increases. As it does so, the color of the distillate changes and becomes quite a dark orange color. Here's the first fraction of distillate collected. Obviously contains some DCM, but it's exhibiting some very unusual behavior, as you can see here. It's water reactive and creates a milky precipitate in contact with it. The temperature then rose to 120 degrees C, and clouds of smoke began to appear in the apparatus. We've now got a milky yellow liquid distilling off. The visible liquid in the boiling flask is now down to a small amount, and we've got some sulfur dioxide gas being produced and emitted from our apparatus. There's clearly something higher boiling left in the flask, so we keep going. But the maximum temperature that the distillate vapors reach are 140 degrees C, just for a short period. We keep collecting the distillate, which is coming off at 120 to 140 degrees C until nothing more comes over. At this point the contents of the boiling flask appear black and quite charred. We also notice an interesting phenomenon in the receiving adapter and in the receiving flask. Crystals of what appear to be sulfur are forming. This suggests that our intermediate sulfur-bromine compound is decomposing and distilling over. Here's the last fraction of distillate boiling over at around 120 degrees C. It's too low boiling to be propionic anhydride, and too low to be propionic acid even. We placed some into water. The liquid sinks to the bottom in tiny droplets, but seems to react partially on the way. The resulting solution then fumes slightly in air. Well, this sure isn't propionic anhydride, so we're declaring this a failure. After a while all the droplets of the liquid dissolve in the water, forming a milky mixture. Time for preparation method number 2. This is the classical method, similar to the one we used in a previous video for acetic anhydride. We've set up the 250 ml flask with a thermometer. And here's 25 grams of the same sodium propionate we used for the previous experiment. We used the same batch because we wanted to check that this is good quality. Okay, we've got this into the flask. The thermometer is here because, as in the previous reaction, we want to demonstrate how much heat is generated by the reaction. We're starting at just over 30 degrees C. Now we've measured out 17 ml of propionyl chloride. For some reason this has gone milky colored in storage, but it still fumes strongly in air and seems to be fairly pure. So we'll start off and add just a few ml of this to the flask containing the anhydrous sodium propionate. The temperature increase is rapid and dramatic. Just that tiny amount added has taken the temperature up to nearly 65 degrees C. We're going to need to use some strong cooling for this, so we place the flask in an ice bath, and we'll use the glass rod to mix the contents around. So we continue addition of the propionyl chloride in small portions, and mix around after each, allowing the mixture to cool. After a while the mixture forms a fairly liquid slurry. On complete addition we left the flask for 30 minutes and we noticed that the lumps of sodium propionate broke down, forming a fine white powder. The mixture is surprisingly liquid. We set up to distill the flask contents using a simple distillation setup. Some strong heating was required before anything in the flask was visibly refluxing. But after about 10 minutes we noticed some drops of liquid on the inside of the flask, and then slowly creeping up the still head. To begin with we collected just a few mils of liquid which came off below 150 degrees C. Then the temperature rose again and we began to collect the main fraction of distillate. Temperature of the liquid vapor was now 154 degrees C. Distillation was quite rapid. We continued until no more liquid distilled off and the temperature in the still head dropped down again. Here's our distillate. 20 grams of propionic anhydride. This is a 79% yield on the starting propionyl chloride we used. It has a very slight sickly sweet aroma, a bit like propionic acid, but is sharp and slightly lacrimatory, a bit like acetic anhydride is. It also has a slightly fruity note to it. Well, this proves that our sodium propionate is good. So we don't know why the first method didn't work. It's possible that it requires longer refluxing. Or perhaps the DCM affects the reaction in some way. But the fact that we got nothing at all suggests to us that it possibly simply doesn't work for propionic anhydride. Here's a little water in a beaker. Let's drip in some of the product. You can see that it's insoluble in cold water and sinks to the bottom in a round blob. Very similar to acetic anhydride. Hope you enjoyed this video. Stay tuned for more reactions.